Here's our two functions. This time, I'll put g of x in blue, f of x in green. We don't have to graph them this time. It just says find an explicit equation. So our important definition here that we need to know is what explicit equation is, because you've been paying attention, you see me do it, and you go, that makes sense. But when it gets to a test, if you don't know what explicit equation is, that's that key word in this question that's telling you what to do. And that means find an equation with just x's for this. So here it's with functions, g of f of x. We want to write an explicit equation, so we start by replacing the f of x with 1 over x plus 3. And what does the function g do to whatever you put in it? Whatever you put in it gets squared. Then you subtract 4 times whatever you put in it. So if we put in 1 over x plus 3, this is going to equal 1 over x plus 3 all squared minus 4 times 1 over x plus 3. Now, if you wanted to graph this, you could. You could expand it completely, write it as a single fraction, and use chapter 2, which is our rational and absolute value equations and functions, to graph that. Right now, we just have to state its domain. Now, when looking at something for domain, usually it's all values, unless you have non-permissible values. And we'll also experience that you can't take square roots of negatives. So in this situation, are there any non-permissible values? Yes. X can't equal negative 3. Everything else is fine. In B, f of g of x, well, g of x is x squared minus 4x. And if we plug that in to f, we would have 1 over x squared minus 4x plus 3. And so now, what is our domain? Well, if I factor that bottom to x minus 3, x minus 1, can you see your non-permissible values? X can't equal 3, and x can't equal 1. In this one, y can't equal 0. But we're not, yeah. Now, the question I want to do for this one is 6D, and I'd like to do it together. So let's open up our exercises and turn. What's that? And it was a good one?
No. He asked me if page has questions.
Okay, 6D. We've got f of x and g of x, but we don't actually need g of x because we just need to find f of x. I don't know why they gave us g of x. It could have, yeah. Here, extra information you don't need to know. H of x equals smiley face. There we go. Now, all the questions, A, B, C, and D, all had an f of x and g of x, so maybe they just wanted to follow the same pattern. Anyways, f of x, well, f of x is 1 over x minus 1. And what the function f does says whatever you put into it, we do 1 over that minus 1. So if you put in a 1 over x minus 1, you would get 1 over that minus 1. Now, What we have as an answer right now is something called a complex fraction. It's a fraction inside of another fraction. You can't leave your answer as a complex fraction on the final exam, so we need to simplify that. How do we simplify that? Well, we'll use some of the same fraction strategies we used in identities. Can we get a single fraction on the top? Can we get a single fraction on the bottom? Because if we can, then we can do fraction divided by fraction is the same as multiplying by the reciprocal. So how do I get a single fraction on the bottom? Because the top is already 1 over 1. It's a single fraction. But on the bottom, I need to subtract these two things. In order to subtract fractions, I need a common denominator, so I'm going to multiply my 1 by x minus 1, and I'm going to get 1 over x minus 1 minus x minus 1 over x minus 1. Now when we subtract that on the bottom, we're subtracting that whole fraction. So that negative sign is going to get distributed. So we're going to get 1 over 1 on top, and 1 minus x minus a negative 1 will be plus 1 all over x minus 1. So now I have a fraction over a fraction. I can multiply by the reciprocal. And can you see on the bottom you'll get negative x plus 2? So this is equal to x minus 1 over negative x plus 2. We have got our explicit equation. Now to figure out our domain for this one, do we have any non-permissible values? Yes. X can't equal 2. And so most people stop at this point because they see on the bottom that x can't equal negative 2. But you have to check everywhere in your function that you've divided. So if we go back, there's a lot of places we're dividing by other things. There we're dividing, here we're dividing. So we have to include that as well. So we also would write that x can't equal 1.